Greetings, my dear learners. My name is Sarath Kumar. I am working as an assistant professor in Department of Civil Engineering, GC Dharmaburi. In this video lecture, I am going to give an introduction about prestressed concrete structures. So, at the end of this lecture, the students will be able to define what is prestressed concrete structures and able to differentiate between ordinary reinforced concrete and prestressed concrete, and what are the load carrying mechanisms of prestressed concrete structures. And the students will be able to know the two major types of prestressed concrete structures and about the various tensioning devices used in the construction of prestressed concrete structures. Finally, the students will be able to tell the advantages and disadvantages of prestressed concrete structures. So, what is prestressed concrete structures? It is very similar to reinforced concrete structures. In reinforced concrete structures, you will be having a concrete section and you will be reinforcing the concrete section with deformed bars. Here also, in prestressed concrete section, you will be having a concrete section and you will be reinforcing it with not deformed bars but with strands. Here the reinforcement is called strands or tendons. So the overall section remains similar, but the main difference is in prestressed concrete structure, the reinforcement element, the strands or tendons, will be stressed initially. But in reinforced concrete structures, as we all know, the reinforcing bars will not be stressed. Even before applying load, the stress in the reinforcing bars normally will be zero. So what is the difference between prestressed concrete structures and reinforced concrete structure? So as I told, both have similarities. Both have concrete section. Both have some types of reinforcement. This type of reinforcement is to take care of tension while applying load, tensile forces while applying load, because concrete is weak in tension and it's stronger in compression. So, a brief introduction to ordinary reinforced concrete and how it is made. First, the mold is placed. After that, the reinforcing cage is placed in the mold. Once the cage is properly placed, the concrete is poured and allowed to cure and allowed to harden for particular period of time. Once the concrete is hardened, the load is applied on the structure, and once the load is applied, the tensile and compressive stresses will be created in the elements. This is how the reinforced concrete is made. Once the reinforced concrete is hardened and the load is applied, the tensile stresses created in the section is taken care of reinforcing bars, and the compressive stresses will be taken care of concrete. But in prestressed concrete structures, as I told earlier, the tendons, the reinforcing element in the prestressed concrete structure, the strands or tendons, are stressed initially, so that even before you apply load, the stresses will be created in the concrete section. So it is created in such a way that the stresses in the concrete is created in such a way that once the loads are applied, the stresses created due to force applied in the tendons will counteract, nullify the force or stresses created by the imposed loads. We will be seeing in a detailed way little later. So generally, it involves the application of forces tending to bend, compress a concrete element in order to counteract bending, which results from loading. The force applied indicates the tensioning or stretching of steel component, which usually in the form of high tensile strands, wires or bands. Strands are nothing but very thin wires. We have to apply large amount of force to create stress in the concrete before applying load. So here we will not be using 16 mm, 20 mm bars. We will be using very thin, like 5 mm, 6 mm bars, 5 mm bars, 6 mm, 8 mm bars. Normally it is clubbed together. For example, 12 5 mm bars are clubbed together or twisted and made as a single element called strands. So this is the difference between reinforced concrete structure and prestressed concrete structure. As you can see, the first two figures are normal reinforced concrete structures. Once the loads are applied, if the load causes cracking moment, the cracks will begin to appear. Once the crack appears, the concrete in tension zone is useless. It won't take any type of load. So the tensile stresses, the tensile load will be taken care of reinforcement bars. The left hand figure is simply supported beam, whereas the right hand figure is cantilever beam. In left hand support, simply supported beam, the tensile stresses are created at the bottom, whereas in cantilever section, the tensile stresses are created at the top. So how it is different from prestressed concrete, we will see. The second line, the second row is prestressed concrete structures before applying load. So even before applying load, as you can see, as we apply force in the tendons, the concrete bend in such a way. As you can see, in a simply supported beam, we have applied the force in the tendon below the CG. Whereas in cantilever beam, we have applied load in the tendons above the CG. So that when you apply load in the tendons below the CG, it creates tensile forces at the top and compressive forces at the top. Why we have some difference to these two things? We will see. As you know, in simply supported beam, as load is applied, compressive forces are created at the top and tensile stresses are created at the bottom. So, to counteract, to nullify this, we are applying force in the tendon below the CG so that it creates compressive force. It creates compressive force at the bottom and tensile force at the top. So, once the load is applied, once the superimposed load, dead load, live loads are applied, due to superimposed load, tensile forces, tensile stresses will be created at the bottom, which will be nullified by compressive stress that is created due to the force applied in the tendon. Similarly, in the right hand side, in cantilever beam, due to imposed load, the tensile stresses will be created at the top. So, we have to create compressive stress at the top by applying the force in the tendon. So, here the tendons are placed above the CG. So, when you stretch the tendons, it will create compressive force at the top. So, once the load is applied, the tensile force due to the imposed loads and the compressive force due to the force applied in the tendons will nullify, and you will have better resistance to the things. So, as you can see, the reinforced concrete structures compared to reinforced concrete structures, prestressed concrete structure after applying load looks elegant. Looks elegant in the sense it doesn't have any cracks, it has less deflection. Once there is less deflection, there won't be any cracks. And in the main problem in reinforced concrete structures, once the cracks develop, the moisture ingress into the reinforcing bars and started corroding reinforcing bars, and the reinforced bars loses its integrity and the whole structure becomes less strength. But in prestressed concrete structures, there is no cracks and even the deflections are less. So these are the main differences between reinforced concrete structures and prestressed concrete. In a brief, I will tell how the prestressed concrete structure varies from reinforced concrete structures. Both have similar materials, both have concrete structure which is reinforced by some type of steel cell. But in reinforced concrete structure, the reinforcement element is not stressed, but in prestressed concrete structure, the reinforcing element, strands or tendons, are stressed in such a way that it creates stresses in the concrete structure which will nullify the stresses that will be created upon imposing loads. So thus it reduces the cracks and also it reduces deflection. So if we properly design prestressed concrete structure, we will be able to design any element which is free from tensile forces, because it's all concrete structures and concrete is weak in tension. So if we somehow avoid tension in the element will be much stiffer and it will hold its integrity. Means tension cracks won't be developing. So in order to apply force in the tendons, we have to incorporate huge amount of force in the tendons. It will be impossible to apply such force using 16 mm, 20 mm dia bars. So in normal, we will be having strands, very thin wires that can be stressed up to 1600 Newton per mm square, so that we can apply large amount of force in the tendons, which will create stresses in the concrete section, prestressed concrete section. So in the coming lectures, we will be seeing about other learning outcomes. Thank you.